So let me go ahead and get started here. For those who don't know me, I'm Kesha Rogers, and we're going to have, what I'm going to do today is start just brief introductions on the strategic situation, and the speaker today is going to be Joel Dejean, and I'll go into a little bit in just a moment after I finish giving some introduction on what's going on in the world, what Joel is going to be discussing, and the importance of this in relation to what is happening in the world. I think the first thing to note right now is that we're at the very point that Lyndon LaRouche has been warning of, that we're now faced with a situation of life or death for the survival of mankind. Now, the good thing about it is that LaRouche has been the leading figure and of understanding how the strategic picture actually works, and why it is that right now, in the midst of the total collapse and chaos that we've been seeing coming on for quite some time from the transatlantic region, that the whole financial system is bankrupt, that LaRouche said it very clearly in discussions with his executive intelligence, counterintelligence director, Jeffrey Steinberg, that people need not look to Europe and the transatlantic system for sanity or for any type of gravitation of where the world in terms of the economic condition lies, because that's being shifted rapidly. And if you haven't been paying attention, you'll know that the center of gravity in the economics and the world affairs is not in London, contrary to what our maps might say, any longer. And it is not in this collapsing transatlantic system, which is moving toward other chaos through the British Empire and their pawns like Saudi Arabia, Turkey, and Obama in the White House. And these pawns are being thoroughly outflanked, as Mr. LaRouche has very strongly called it, because of their bluff and because of their folly. And the folly is that this system can no longer be upheld. And the key figure of leadership who recognizes that right now is Russia and Putin. And what President Putin has done, going back to when he was here just a few months ago in New York with Obama and other heads of states at the UN General Assembly meeting, and when they tried to make that meeting about the fact that the UN General Assembly was going to discuss the topic of global warming and climate change, President Putin said, he judoed that and said, no, that's not what we're going to discuss. We're going to discuss the implications of what's happening in Syria and the Middle East, and how he had plans already to go in and to do what Obama couldn't and would not and could not do a whole year plus prior. That Obama had been talking about how he's going after ISIS and he's taking down ISIS and Al-Qaeda and the Islamic State. And there was no reality to that whatsoever, as we know from the standpoint that Obama not only continues to defend Saudi Arabia and to defend those who have been arming and funding ISIS and these groups, but on top of that, he's continued to be massive opposition to what Russia and Putin has represented as a real flank. Now, the insanity of that Obama opposition to Russia continues to deepen, and the reality is that now you have the lunacy of Erdogan in Turkey, and after Erdogan went in and had the attack just about a year ago on Russia, the situation has continued to escalate. Now, more people in our military and other factions recognize that we're heading down the road toward utter destruction, that the continuation of the escalation of feeding tensions between Russia and Turkey by the United States and by the British, and now also Saudi Arabia, can and will lead to a nuclear confrontation if this is not stopped. But let me just give a couple of highlights on what some of this, first of all, some of what's coming from Obama and these networks that are acting on behalf of the British, and then I'll go through a little bit of the opposition to that. First of all, let me just say that one second. So Russia went to the UN Security Council because many people know that what Erdogan has now initiated with the unleashing of attacks on Syria by being supported by Obama. Obama called the president of Turkey and said that we will continue to support your efforts. He then went on to say, but you have to back down and stop the missile attacks into Syria. But the interesting thing about it is that he then went on to say that the Kurdish opposition had to stop making headways in terms of their territorial gains against ISIS and al-Nusra. So Obama had an hour and 20-minute discussion with Erdogan, and it was, basically a bunch of BS, because what's going on right now is that they're still trying to play Russia and Putin for a fool and thinking that they have him cornered, but in reality, he has them cornered because he has done the only thing that offers a real strategic flank in Syria, and now you have what Putin just did in going to the UN Security Council, and the opposition coming from the nations of France, the United States, Ukraine, and other people show how desperate and how insane this process is. Because what Russia did is they went to the UN Security Council and they proposed a resolution against what Turkey is doing, and said that we have to call for the return to sovereignty in Syria and territorial integrity. And the number one, I don't even know what you want to call her, crazy lady, Samantha Powers, came out in opposition to this as a spokesperson for Obama, in saying that U.S. completely opposes this resolution, and said that the resolution is distracting attention from peaceful solutions. The great peaceful solutions that President Obama is putting forth is being distracted by Russia and their resolutions. And of course they said, well, if this is this, what peaceful solution? Exactly, that's Libya, Iraq, peaceful solutions, sure. And said, so this is distracting from discussing the territorial integrity of sovereignty of Syria. So that was the insane remarks coming from the representative in the U.S. And then you had the president of France following up on that, President Hollande of France, who said that there is a risk of war between Turkey and Russia over Syria, and that this is all Moscow's fault, and Russia should stop backing President Assad in Syria, and then he went on to go into more, I don't even need to go more insanity about how Russia is killing civilians in Syria and so forth. So this is what you're dealing with. These guys are at a point right now where this is complete folly. They have no power, no control. I think what Mr. LaRouche reiterated very well, that the center of gravity in terms of where the world is going does not lie with the British Empire. And it does not lie with the City of London. It lies with Eurasia, China, Russia, India, these nations that are representing a moment of sanity, imposing a new paradigm for the nation, and many people recognize that and know that. Now, on the opposition that you're seeing to this threat, which people know if it's continued to be escalated will lead to a extermination of the human race, because that's where we're at right now. We're at a toe-to-toe, but that can be changed and that can be reversed with sanity. And Russia knows that that's not the direction we need to go, and they're doing everything in their power to try to stabilize and stop that situation. China knows that, and China's leading on a magnificent front. And many people, everybody in the U.S. military and government is not insane either, including looking at this report. There's a letter that now has been written by 6 members of the U.S. Senate, which include Bob Coker, Tim Kaine, Rand Paul, Marco Rubio, Ron Johnson, and Tom Udall. So Republicans and Democrats. And in this letter, it's very short. I'll just read it if I can, because I printed it very small. Anyway, it says, the Honorable John Kerry, the Honorable John F. Kerry, Secretary of State, U.S. Department of State, blah, blah, blah. I won't go through all that. Anyway, it says, Dear Mr. Secretary, we write to express our deep concern about the recent Turkey's artillery shelling of Kurdish-held areas in northern Syria. Our allies from the Democratic Union Party and the People's Protection Units have been unwaveringly committed to fighting the Islamic State terrorists, and it is the responsibility of the United States to render comprehensive assistance to them. We cannot turn a blind eye to the blatant violations of coalition agreement, even if it has been done by our investigating NATO ally, Turkey. To keep out of its means, give Turkey carte blanche to destroy. I'm sorry, I printed that too small. The words are not coming out, but I'll just tell you basically what it says. It says that, one, we can't allow for Turkey to go in there, going with Erdogan, going off the handle, going crazy, and continue to create these situations in Syria that can lead us into an attack with Russia. And that there has to be discussion. There has to be rational discussion. Erdogan does not have the right to just go in there and do what he wants to do. And recognition that the situation in Syria is getting out of control, and something has to be done about it.
Do they name Erdogan?
Yeah. Mm-hmm. It's that situation in Turkey. Yeah. So now, the other thing, and when I get that bigger, I can read it to you guys. I'll lose my eyesight if I try to read that. Now, the other thing in terms of opposition is that there was just to further elaborate on this threat and the recognition of that there is a consortium of forces being led by the British Empire, which includes Saudi Arabia and include these networks. So there's former Secretary of State Bob Perry, and he has a report called Consortium News, and he put out that Obama is refusing to tell Turkey and Saudi Arabia to stand down. Obama did not answer the question of whether he is encouraging Saudi Arabia and he is encouraging these moves in Syria. But he says, and so the situation right now, he goes on in this report to talk about the danger of Obama protecting and saying that we are going to back Turkey in Syria and this repercussions of this on Russia in terms of what this can create. So again, you have a British Empire that has been outflanked very thoroughly by Russia. Russia knows what the story is right now. And what Turkey and Saudi Arabia are doing is acting on the basis of complete insanity, as a complete folly, and that they cannot continue to win, or they will not win in this circumstance. So now this gets us to the question of what our responsibility is, and what is going to move the population to understand, and that's what we all have a responsibility to communicate, that we're at a moment of decision for the nation and for the world. What you're seeing right now in terms of the narrative, the so-called narrative in the media, is not addressing reality. It is completely on the side of the British Empire in thinking that this bankrupt financial system of the transatlantic system can be sustained. It can't. People know that the there's utter chaos going on in terms of the ability of the EU to continue to push through its bail-in, bail-out policy that is triggering more effect toward the drive for war. Now, I will say one additional thing in terms of this war drive is a lot of people may have heard that Obama initiated or basically, I guess, signed the orders, should we say, for attacks in Libya without any. There's no government, no one gave them permission to go in and make these recent attacks in Libya, which now come to find out that the facility that they targeted, that they ambushed, was actually harboring two diplomats, Serbian diplomats in them.
You're talking about 2011 or something more?
I'm talking about right now, like
last
I'm
sorry, who's harboring what?
This was Libya. There was U.S. attacks on Libya, which actually, in the facility that was attacked under orders of Obama, which nobody called them, so supposedly no one called them in from Libya to actually make these attacks. They did it unilaterally on their own by orders under the administration. I don't have the full picture on it right now, but now what's come out in the last few hours is that there were Serbian diplomats too in that facility that was targeted that got killed. Now, this just the point I'm making on this is that there's utter chaos, and the chaos is exploding because you have an empire that's now being brought to its knees, and they know that they are losing power. Now the question is whether or not the American people can shirk the insanity and rid themselves of the opposition to joining with the real force of leadership in the world right now, which is Obama and the British Empire. We have a moment right now where Obama has to be forced out, thrown out. He's already been weakened, and the thing to do that, we have the 28 pages, which still has to be put fully on the agenda to expose the crimes of the Bush administration before in protecting Saudi Arabia, Obama's continued protection of Saudi Arabia and the British Empire, and the crimes that led to the attacks on our United States, but also the fact that this is the grouping that has continued to be the #1 funders of arms and funding to the terrorist networks. And Obama's backing this, Obama's supporting this, on top of his other crimes. It can be out. More people are starting to come out and recognize the danger that we're in right now. But the question is, recognizing that is not just enough. It's not enough. What we have to address now is where we go from here. Let's get Obama out, shut down this bankrupt system, and organize a new direction for mankind, which is already being set into momentum, has been set into momentum by what Russia and China are doing. And so I think that's what we have to now address. And I'll just take a five more quick minutes here to show the moment of optimism that we have in the country. And this is what I'm going to use to lead into Joel's discussion, because the key thing right now is, do people have an understanding, first of all, of what the mindset of the American people has to be to restore a sense of the understanding of our unique responsibility in the world? You know, looking at what I just presented right now, the whole world is looking at the United States and saying, my God, what happened to the United States that we knew? That was the beacon of hope for all mankind.
Temple of Liberty.
Yeah. And, you know, what happened to the United States that had fostered the minds of great leaders such as President John F. Kennedy? And in a moment like this that we're facing of great tragedy in the world, you know, you remember John F. Kennedy's words and what he had to say in his first inaugural address, I think, gives us an insight into the type of leadership and the type of mindset that we need for today. And what Mr. LaRouche has initiated as a powerful flight to pulling the population out of the depths of this despair, this chaos, and saying we can move forward with a real mission for mankind. That mission for mankind that Mr. LaRouche has initiated, and I'm taking full responsibility in leading in the restoring of our space program, has to be at the forefront of understanding for everyone. And that's exactly what President Kennedy understood. This is what was going to be the flank to the threats of war, to the oppositions that nations were facing. And he says it very well himself. In his January 20th, 1961 inaugural address, President Kennedy challenged the powerful nations who stood in conflict with each other. And he saying that they had to begin anew in a quest for peace. And so then he declared, quote, "Let both sides explore what problems unite us instead of belaboring those problems which divide us. Let both sides, for the first time, formulate serious and precise proposals for the inspection and control of arms, and to bring the absolute power to destroy other nations under the absolute control of all nations. Let both sides seek to invoke the wonders of science instead of its terrors. Together, let us explore the stars, conquer the deserts, eradicate disease, tap the ocean depths, and encourage the arts and commerce. Let both sides unite to heed in all corners of the earth the command of Isaiah to undo the heavy burdens and let the oppressed go free.
That was JFK?
That was JFK's first inaugural address. And now, China and Russia recognize that that is our human moral responsibility right now in terms of what they are putting forth as a solution, what China calls win-win cooperation amongst nations, and the development that we have a responsibility as a species, mankind, to go out and explore, conquer new frontiers, space, and that we got to do this together for the betterment and the common interest of all mankind. And so that's what China is doing in terms of their leadership, to that our first step to achieving that boundary has to be getting back to the moon, fully developing the moon, understanding that there is a unique opportunity in terms of the resources and the development of transitioning mankind through all cislunar space into other parts of the solar system, into other parts of the galaxy. And this is what leading pioneers of science actually recognized was our mission. And that has been destroyed by Obama with his insane continued cuts to our space program, manned and unmanned space program. And it also is continuing to be cut by Obama's destruction of our commitment to go back to the moon. So that's the first step to our endeavors of reestablishing a sound space program. And now you have a situation where we have to rapidly move in terms of our understanding of what it is that is the responsibility of mankind to realize his own true self in the solar system, who we are as human beings. And so the last thing I want to state on that is that the recent developments on the genius of Einstein comes very much into focus. And this is what Dejean will go through in just a moment here, in terms of what we're now investigating and seeing is not the solving of some mathematical equation, black holes, not black holes, anything of that nature. But if people have looked at what's happened with the recent developments of the findings of gravitational waves and what this represents, Mr. LaRouche is seeing this as a breakthrough in the development of mankind's understanding of their own mind, and that genius is in the universe and can be known. And so now this gets to a question of how we actually expound upon that discovery, that we are just beginning. We are just beginning to discover things about the universe that we did not know. And so we got a lot of work to do, and that's going to be a lot of fun. So that's a whole lot more fun than having to deal with Obama and thermonuclear war. Even if you don't disagree and we're arguing about whether or not it's a true discovery or not a true discovery, regardless, the question is whether or not that's going to be the intention of mankind. Is that's where our focus is going to be, and not on whether or not we're about to be blown up. So I think
You're aware that there is a controversy over this?
Oh, of course I'm aware there's a controversy over this, but that's good. There could be a controversy. So, but we're going to let Joel give his presentation right now, and then we can have some discussion and questions and controversy right after. All right. Okay, go ahead. Okay.
Marker.
There you go. And then the board is straight behind you. Hold on 1 second.
Well,
And
I'm
there's a
sure.
cord on the floor, yeah.
Yeah.
She's gonna move it.
Just trying to trip me up here.
Yeah.
I'm sure you all felt the wave last September. You may not have realized what it was. But what I want to go through is what was detected, and just as important, how it was detected. And what does this have to do with the price of tea in China? And what does Einstein have to do with it? Now, first off, this is the first wave that I know of.
I'm behind you, don't move that.
Okay, clear?
Go ahead.
Okay. All right. Clear? This is the first wave I know of that has a name. It's called GW 50914. And the GW is not for George W. It's for gravitational wave, and the date it was detected was the September 14th of last year, 2015. Now, before I get into the gravity wave, what is a gravity wave? I wanted to go through a little bit about electromagnetic waves, electromagnetic radiation. Now, does anybody know what discovery Einstein earned his Nobel Prize in physics?
Theory of relativity?
No.
No,
Photoelectric.
correct. Photoelectric effect. Now, back in the 1905, Einstein wrote a series of papers which included special relativity, the photoelectric effect, and it was 10 years later that he discovered and wrote out his discovery on what came known as general relativity. Now, just to go through what the photoelectric effect is. This was something that came out of the discovery of Max Planck back in 1900, where he discovered that energy is emitted not in a continuous way, but consists of discrete packets of energy. And what Einstein further discovered is that light itself is not just a continuous wave, but also consists of discrete packets of energy. Now, just to give you a little general review of what a wave is. A lot of young people have never seen this. This is part of a landline. Everybody's wireless now, but now you can think of this as a wave. If you look at the peak to peak, that's the wavelength. The number of cycles, which is the number of wavelengths hitting a detector per second, is the cycles per second. So a wave, any wave, and I'll concentrate now just on electromagnetic waves, there's a certain relationship between the speed of light, which is c, is equal to the wavelength times the frequency. And this is true for all waves. Now, what detected this gravitational wave is an experiment called the Laser Interferometer Gravitational Wave Observatory, or LIGO. And it consists of 2 detectors, one in Livingston, Louisiana, and another 2,000 miles away in Hanford, Washington State. Now, what the scientists and engineers figured out is that in order to detect the gravitational wave, now, just to give you some idea of the scales we're dealing with, again, we're looking at something in the universe which is billions of light years away. Now, just to give you some of the scale, the speed of light is 300 million meters per second. Now, just to give you some idea of what that represents, and I happen to have my meter here.
Oh, yeah?
If you say this is 1 meter,
Okay.
light travels, if you fold this over 300 million times in 1 second.
Basically, here to the moon in 1 second.
Exactly.
Wow.
As a matter of fact, we measure distances now by using the speed of light. And the meter, which was developed in the 18th century as a metric of distance, is a standard meter which is held in Paris, made of, I think it's platinum.
Yeah.
And it's held in a laboratory in Paris, and it was used as the standard meter. Now, the way they measure the meter is not with some piece of metal, but they use the distance traveled by light in 1/300 millionth of a second. And the distances to the stars is measured in light. It's measured in light years. So 1 light year is the distance traveled by light in 1 year, which is close to 6 trillion miles in 1 year. Now, we've all traveled in cars at 60 miles an hour. I'm sure everybody has traveled in a jet plane that goes about 600, 700 miles an hour. A light ray travels 1,000,000 times faster than any jet aircraft.
Yeah. Wow.
So it gives you some idea of the speed of light.
Yeah.
Now, in this experiment, the LIGO experiment, there's another acronym in this experiment called LASER, which stands for Light Amplification by Stimulated Emission of Radiation. And without Einstein's discovery of the photoelectric effect, we would not have lasers today. As a matter of fact, we would not have most of the electronics that we use in our iPhones today. Now, what Einstein and Planck discovered is that energy of a wave is equal to a constant times the frequency of the wave. And that's for all electromagnetic radiation.
Could you restate that again?
That the energy of a wave, of the quantum of each photon, is the frequency of that wave times a constant called Planck's constant.
So you wrote E equals HV?
Right. V is it's supposed to be in Greek nu.
Oh, okay.
So frequency, and again, just to reference the wave, wave consists of 3 basic units. You have the speed of the wave, you have the wavelength, and you have the cycles per second. So the more cycles per second, the more energy dense you get out of the wave.
Oh, okay.
Now, to go through what was used to detect the gravitational wave, it's called the LIGO, and I happen to have my own personal LIGO.
You do.
what they do with waves is that for this particular experiment, they had one arm of the experiment where they shoot the laser down. First they use an infrared laser, and they shoot it through a beam splitter so that half the light goes in one arm and the other half goes at right angles down the other arm. These arms are 4 kilometers long, about 2.4 miles. And what they do is they shoot the laser, it goes to a set of mirrors. And the mirrors are suspended at the end of these tubes. These tubes are about 1.2 meters. They're evacuated, there's a vacuum. And so the laser light hits the mirror. The mirrors are suspended on fibers, very thin fibers, to isolate them from vibrations from the surroundings. The mirrors, they've upgraded this detector so that each mirror is about 40 kilograms. Because light, although it has no weight, it has pressure. And they don't want any distance coming just from the light hitting the mirrors. So you have a set of mirrors on this arm, and you have a set of mirrors on this arm. Now, if you split a beam of light, send it to a mirror, and it bounces back, and what they do is they bounce it back and forth 100 times. If the distance between the laser source and the mirror is static, that there's no change, and these are equal lengths at right angles, when you recombine the light, or the infrared light, if the distances are equal, then you won't have, it's called an interference pattern. The wavelengths will overlap. If there is a tiny shift in distance, either in this arm or the right arm, then you'll have what's called an interference pattern. And from that interference pattern, you can detect various information from the source of that wave. Now, just to give you an idea of what they're looking for. Yeah. What Einstein discovered with the special relativity had to do with the speed of light. And what he discovered is that both the distance and the time is relative to the movement of the observer. But one thing remains constant, is that the speed of light is constant, no matter if you're moving 60 miles an hour or 600 miles an hour or half the speed of light. That is the constant. Now, what he developed 10 years later in Berlin is the idea that not only is there relative motion with a constant velocity, but with an accelerated, through acceleration, you have space is no longer absolute, time is no longer absolute, but you have what's called a space, the fabric of space-time. And what he discovered is that gravity is not some force operating at a distance instantaneously, but gravity is actually the curvature of space-time under the effects of a large mass. Now, just to give you an idea of what they look, I happen to have a tissue of the fabric of space-time. So what you have, say this is space-time. What Einstein postulated is that gravity is simply the effect of a mass on the fabric of space-time. So this is not the official black body, but this that with a heavy mass on the fabric, you see that it curves inwards. And gravity is simply the effect of the acceleration of mass on the fabric of space-time. Now, a year after Einstein's formulation of the general theory, he postulated that if you have two masses accelerating toward each other, that you would have such movement in the fabric of space-time that you would develop what's called a vibration or wave in this fabric of space-time. Now, what he worked out is that the amount of movement that would be detected on Earth from the movement of these two massive bodies on each other and their effect on the fabric of space-time would be the equivalent of 1,000th of the width of a proton. So if you think about it, in order to detect one of the most massive events in the universe, you have to get down to the level of the very small. And just to give you some idea, if we were to cut up a meter by 100 times, you have 1 centimeter. 1 centimeter, just to relate it to an inch, you have about 2.5 centimeters in 1 inch. If you cut it by 10, you get 1 millimeter. So you have 25 millimeters in 1 inch. If you cut that up again, you get the micrometer. And if you go again by 1,000 down to the nanometer, you get the etchings on your electronics. Right now, most electronics, most of the components on this iPhone, the etchings are about 10 or 20 nanometers in thickness.
Wow.
What,
Yeah.
Siri keeps speaking out. What we're looking for with this gravitational wave is something in the order of a trillionth of a billionth of a meter.
Whoa.
So if just to give you the exponentials, you're looking at 10 to the minus 21 meters. So if you think of a billionth of a meter, then you go down, down, down to less than a trillionth of a billionth of a meter is what we're looking for. And 100 years ago, there was no way we could detect that. So Einstein went back and forth. He said, well, these waves might occur, but we will never be able to detect them. Now, in 1958, we discovered, using the photoelectric effect, that if we pump up the gas with energy, either from flash lamps or capacitors, we can excite atoms in the gas to a higher state. When they come back to the lower state, they will emit a coherent beam of radiation. That was the discovery of the laser. So using the concepts that Einstein discovered with his colleague Planck back in 1905, you can create a beam of light that is completely coherent, and you could use that as your yardstick to measure distance. So this LIGO experiment began back in 2002. It was first tested in 2002. They ran experiments up to 2010. And with all of their measures to isolate the arms from any vibration, they have accelerometers, they have radio detectors. And like I said, they keep this tube in a vacuum. They have the mirrors suspended. They have servo motors to keep vibrations from large trucks and trains. And they have seismometers so they can detect, is there an earthquake in the area? And they use 2 of these because if you detect a wave in one of them and in a certain time lapse, you don't detect the wave in the other instrument in Washington, say, then there is some kind of noise that you're picking up. But if you detected the vibration in one of them and say 100 milliseconds later, you detect the similar vibration in the other detector, it's like your ears. You can hear the noise coming on this side and you can hear on this side. Then you could tell which direction the wave is coming from. So what they did over the last 3 years is they upgraded the laser. They increased the power of the laser from something like 10 watts to up to 700 watts. They increased the weight of the mirrors. They refined the electronics. So they turned this thing back on in early September. And they ran through a series of tests and they detected this wave, and the frequency they're looking at is from 75 hertz to 300 hertz. And they detected a peak at 150 hertz. Now it's almost like going from low C on the piano to middle C. Not quite 250 hertz, but 150 hertz. And the wave came down. They ran through all sorts of operations to filter out any noise. They determined they had a high confidence of their signal to noise ratio. They ran all sorts of checks on this, and they published a paper last Thursday saying they had discovered this for the first time, discovered this gravitational wave. Now, this is not the end of the story, because the longer your arm, the more accurate your detection. So what is proposed for the say the next 10 to 20 years, both the Chinese and the Europeans are working on this, is to put this out in space. They have a proposal for something called the LISA, the Laser Interferometer Space Antenna, where instead of this just being 4 kilometers, you can put satellites in very stable orbits, millions of miles apart, at right angles to each other, and run the experiment and see if you detect the wave.
Do they have that now, Joel?
No, this will be in the next 10, 30 years.
Wow.
And I think Jason mentioned last night that Obama has cut US participation to this LISA antenna program. Now, what's the big deal? Well, if you look at what we have discovered using just electromagnetic radiation, visible light, using optical telescopes, we made all sorts of discoveries with the Hubble, additional discoveries. With X-ray satellites, we look in the X-ray spectrum, additional discoveries. With gamma ray satellites, we can detect gamma rays. Now we have a new spectrum, not in the electromagnetic spectrum, but actual gravity waves, where we can detect what's going on in the universe in a region where we had no capability before. It's been mentioned, it's the equivalent of we've had eyes to see into the universe. Now we have ears so we can listen to the universe. Now, what discoveries this may bring us, I'm sure it'd be more useful than another app for your iPhone. But if you just look at what they say, these 2 black holes that merged, one was 36 times the mass of the sun. Just to give you some idea, the sun is 880,000 miles across. The Earth is only 8,000 miles across.
How about the diameter?
Diameter, yes.
Wow.
The sun can contain within its volume 1 million Earths.
Wow.
The weight of the sun is something like 300,000 times that of the planet Earth. Now they're detecting masses that are 30 or 36 to 29 times more massive than the sun. And what produced the wave is the merger of these black holes created a single black hole that was 60 times the size, the mass of the sun. So a large amount of that mass, original mass, was converted to energy, which the other most famous formula that Einstein is known for is that energy and mass are equivalent. So if you change a little bit of mass into energy, you multiply that mass by the speed of light squared. And remember, the speed of light, 300 million meters per second. You square that, you get 90 quadrillion. So imagine if you had $1 and you multiplied it by the square of the speed of light. You have 90 trillion, quadrillion rather. And then you could wipe it out by betting in the bond markets. But to give you some idea, what they estimate is that the conversion of that, they say 3 solar mass equivalents into energy equal the energy output of the entire visible universe by 50 times in that 1 second when that merger occurred. Now, the idea is not just to sit on our laurels and say, well, we discovered this wave. You have to build the bigger instruments, you have to fine tune it, you have to reconfirm it. Now they're building a similar LIGO in Italy. The Indians are building or planning on building one in India. The Chinese are planning on building both ground-based and space-based interferometers. And if you look at the end of the report that was published last week, you have a whole series of universities that collaborated on this, from California Institute of Technology to Louisiana State University to the Lomonosov University in Moscow, Chinese. So you have an international collaboration already with this type of program. And if we were to have a real commitment to going back to space, to actually exploring, not only detecting these phenomena, but coming up with new concepts. Because if you think of all of the science that's gone into these various receivers and antennas, we're still operating on the breakthroughs that were made in the beginning of last century, 1900, 1905, 1915. And I think it was Jason that said last night, where are the new Einsteins? We need to make new discoveries. And if we were actually to have a commitment by the United States to join with China, Russia, India, Sri Lanka, all of the nations of the world could contribute to this, then we would have something to actually work on it. And I just finished reading another book by Edward Teller, which was written in 1987, called the Better a Shield Than a Sword. And at the very end, he gets real philosophical. He says, he goes back to Plato's Republic, and he says, should we now, the philosopher kings, will now be the scientists who have the knowledge to steer the society. But he rejects that, and he says, no, it should not be just the scientists, that we have to have an education of the populace so that they can understand not all the details, but understand the concepts and participate in the new discoveries and participate in their governments. So it's a very strong polemic against this idea of just an aristocracy that can direct this. So if we look at what's been discovered, it's just the tip of the iceberg of what we should and could be doing. So I'll leave it at that. And
that last point you made is interesting because it flies right in the face of Russell, who thought that there only should be a small aristocracy that will participate in this discovery, and the population should have, in these great scientific discoveries, the population should have nothing to do with it whatsoever.
Right, they should be automatons.
Yeah.
And not only that, the only reason why the British elite kept some scientific capabilities is to produce weapons. Produce weapons of mass destruction. So as Taylor says, it's better to have a shield than a sword.
Oh.
But that's going to take the participation of the population, not just in politics, but in science and in new discoveries. So I'll leave it at that in this debate.
Does the word LIGO, I'm sorry, I'm trying to understand the, because you talked about splitting the light and having it go in a right angle. Is that the LIGO, is that what you mean by that? Or
Right.
LIGO is,
What it stands for is Laser Interferometer Gravity Wave Observatory.
okay,
Now, the interferometer is that if you have a beam of light or any light, and you split the beam, and you have it at right angles to each other, and they bounce off mirrors, when they recombine, if there's no motion in your, if your apparatus has the same length of both arms, and you use the laser as your yardstick, as your measurement of the distance of these arms, what you're looking for is a small change in distance of the arms when this wave comes through. And as I mentioned, the distance involved is a trillionth of a billionth of a meter.
my goodness.
So you're looking for a very tiny difference in distance between the arms, because if a wave comes through, this arm will lengthen while this arm shrinks.
Why will it do that exactly?
If there is a wave, you see, you're sitting on the Earth, and Earth is in this universe of space and time.
Right.
And if there is a gravity wave coming through from a distant event, as it comes through, it will
It pulls.
lengthen one arm and shrink the other arm because of the way you have a wave coming through.
Oh, so it's pulling on it. The gravity of it is pulling the force
Right,
of it.
it's changing the distance.
Changing the distance. Huh?
Right, either lengthening it or shrinking it.
Shrinking it.
And you can detect that distance change by, if the light coming back to the detector is just a little bit off, then the wavelengths will no longer match, and you'll have an interference pattern. You can see this if you use water and you have, this is a double slit experiment. If you send a wave of water through a double slit, then the wave will go through the slits and cause an interference pattern. The same thing with light. If you send light through a double slit, the waves will recombine on the detector, and you'll have a black and light spots. You'll have a pattern of interference. Using that pattern, you can tell how much distance the light has traveled. And if there is a difference, you're looking for the difference in length of these two arms. You can detect that by using a detector that recombines the light, and if nothing is moved, then you get a no result. If there is a wave that comes through and moves the arms ever so slightly, then you get an interference pattern which you can then use to say how much the arms have moved. And using that knowledge, you can tell the distance of the wave, where it came from, and use two detectors, because you have one in Louisiana. If there's some kind of earthquake, or if you're doing shale oil, or if you have a shale oil earthquake in Louisiana, you probably won't have the same thing in Washington State, 2,000 miles away. And if the same disturbance hits the detector in Washington with the same amplitude, the same phase difference, And if the time it takes to go from Louisiana to Hanford is in the right range, say a few milliseconds, because a gravity wave travels at the speed of light. It's not instantaneous. So that if you make a measurement in your Louisiana detector and the one in Hanford has no effect, then you say there was some kind of noise. But if you detect something in Louisiana and you detect the same waveform in Hanford within the right time frame, then you can say, well, that is coming from the southern hemisphere, the southern part of the southern portion of what Earth is facing. And you could use that, it's like having two ears. You can use it for distance, tell where the noise is coming from, where the signal is coming from.
So is a gravity wave, so you're saying it's not a light, gravity wave is different from a light wave?
Right.
It's supposed to be a wave on the fabric of space and time itself.
That is, how do you see, I mean, how do you?
You can't see it, you have to
Okay.
measure it
It's kind of like
here.
believing in the Easter rabbit or something like that.
That's what
No, because
Yeah, how do they?
here's the thing is
How
that,
do they see the evidence?
have you ever heard of Vulcan?
The Vulcans?
Vulcan.
You mean in like Star Trek?
No,
I'm sorry.
that's what I was getting at. Is that not where Spock was from, but
Okay.
back in the 19th century, in 1950, you could use gravity to detect a planet, because in 1781, William Herschel, using optical telescopes, looking at the sky, he discovered that there was a light, faint light moving.
By his eyes?
The telescope.
A telescope, okay.
It was too far away.
Uh-huh.
And he discovered Uranus. It wasn't Barney Frank. It was Herschel. Okay, so he discovered a planet. Now, they observed Uranus. Now, the orbit of Uranus is something like 200 years to travel around the sun. Using his knowledge of where this new planet was, he discovered there was a wobbling in the orbit of Uranus. And in the 1850s, someone looking at that shift in the orbit said, there must be another planet affecting the orbit of Uranus. And using his estimate by the effect of gravity on this planet, they discovered Neptune using optical telescopes. Once they figured out where this gravity effect was occurring, they looked using high-powered telescope and they discovered Neptune. Now, it's the same person looking at Mercury. There's something in the orbit of Mercury called the perturbation of the precession of the perihelion of Mercury.
Say that again?
Mercury, as it goes around the sun, you have the furthest distance from the sun and the nearest distance. The perihelion is the nearest it comes to the sun. Its orbit is only 3 months around the sun. And it is affected by the other planets, especially Jupiter, so that every revolution, Mercury does not come back to the same point in the sky. It proceeds, there's a precession. What they did in the 19th century is they said, well, there's something going on. There's Mercury's orbit is a little bit off because it's being perturbed. And they figured, well, we discovered Neptune using this method. There must be another planet closer to the sun. And since the sun is hot, and they said, well, that planet we'll call it Vulcan. And you had astronomers actually seeing something across the sun, the surface of the sun, and saying, aha, we discovered Vulcan. But they were never able to repeat this throughout the 19th century. Now, Einstein comes along and says, well, the gravity is not just a force of two masses which are related to the square of the distance between them. The closer they are, the stronger the attraction. What he said is that gravity is not just some attraction. Gravity is a curve in the fabric of space.
Gravity is a curve. Yeah.
So that, you see, it's flat here,
No, it's like,
but you see, it's dented. It folds. It's
Because
like,
it's forcing, and you have force coming down on
this fabric.
Yeah.
Yeah, think of a trampoline.
yeah.
I was wanting to get trampoline in here, but if you have a bowling ball in the center of the trampoline, and you send marbles towards the bowling ball, they'll start to spin around the bowling ball because of the indentation of that trampoline.
Right, the bowling ball on the trampoline.
Right. And what Einstein did, even before he postulated gravity waves, he said that the reason why Mercury is moving, there's a perturbation, is because it's so close to this massive sun that its orbit is being influenced by its nearness to the sun. And because of his general theory, he was able to destroy this idea of Vulcan.
Of what?
Of the idea of another planet inside the orbit of Mercury.
So he's the one, so it was Einstein who was able to destroy that idea that there's a planet between Mercury and the sun.
Yes.
Uh-huh.
He said that the reason why the orbit is not what we calculate using what they say Newtonian or Keplerian orbits is because the gravity is not just being caused by the attraction, it's warped in the space-time. Now, the other thing is, this is what made Einstein famous. In 1919, he said that just as a mass will warp the fabric of space-time, he said that light, which has no
Gravity.
electric, right, it has no mass.
Mm-hmm, no.
But he predicted that light coming through this region of space around the massive object will bend. Now, the problem is you need a large mass, something like the sun. So in order to test this, you have to have an eclipse of the sun and a star that is behind the sun. As the sun moves, the star behind the sun is right off of the rim of the sun. But normally you can't see it because of the brightness of the sun. If, however, there is an eclipse of the sun, because the moon comes between us and the sun, then that cuts down the brightness. You can take a picture of a star behind the sun. And he predicted that the light from that star coming through the field, the gravitational field of the sun, will bend. And a British astronomer called Eddington knew that there was an eclipse of the sun coming up in the spring of 1919. And this is right after World War I, where all the ties between the scientific community of Germany and England were cut.
Mm-hmm.
You had a key physicist who, using Einstein's formula for general relativity, worked out that under certain conditions you would have what's now called a black hole. This guy named Schwarzschild figured this out while he was at the Eastern Front fighting the Russians. And he was killed, but his idea is now called the Schwarzschild radius. Max Planck's son, one of his sons, was killed during World War I. So you had this horrible war. But this British astronomer, Eddington, who was a Quaker, was against the war, like Einstein was against the war. he said, I'm going to test Einstein's theory. I'm going to go to this island right off the coast of Africa. And it's supposed to be the best place to see this total eclipse. And he went, he set up his equipment, and there was cloud cover.
Oh.
And the clouds parted, and he was able to take photographic plates of the eclipse. And examining the plates, he was able to see that this star that was right behind the sun had deflected 1.7 seconds of arc, exactly as Einstein had predicted. So that light bends, and there was headlines in the London Times and the New York Times saying, light is askew, Newton is overthrown. So
Really? That was in the New York Times?
that was, yeah, I think it was, there was a slug in the ops that Richard Black had.
Oh, yeah, I had read that, yeah. So is it bending because of gravity pulling it, or what is it bending?
What happens is that, say, if you have a beam of light coming from this side, say in the middle of this at the midpoint, going left to right, and if this room is being accelerated upward, say this room was being pulled by some giant in space, and he was accelerating us upward, the light coming in here, because of the movement of the whole room up, by the time it got to the other side, instead of hitting the midpoint, because the room is moving upwards, it would hit lower in your frame than if it was just a straight shot. So under the effects of a gravitational or acceleration field, it will bend. And that's what was discovered in 1919. And that's what made Einstein the most famous scientist in the world.
He never got a Nobel Prize for relativity, and there's a reason for that.
Because most of the scientists at the time disagreed with
Einstein.
his idea.
Yeah.
No, I think it had something to do with Dayton Miller and rewriting that Michelson-Morley experiment, not having it fail. Okay, and that just shoots relativity down. Now, you've got like Ron Hatch, who holds most of the meaningful patents on GPS, right? Who describes relativity as a bunch of BS. He says that GPS works in Newtonian physics, and trying to make it work in Einsteinian physics wouldn't work.
This time, absolute.
Yes.
Is time absolute?
Yes. Time is absolute. It's like.
Then why do they have to adjust? Every global positioning satellite has an atomic clock, and that atomic clock is using a
It was easier time believing that a clock could work differently because of that, altitude and motion, or the time itself is going to.
The time on the clock is different than the time on Earth.
It's just a difference in the way the clock is working. Okay.
It's the same clock. It's a cesium atom atomic clock using the same cesium atom. Cesium would.
There are things that would make it run differently. I mean, going one way or the other, different altitudes. Now, let me tell you what gravity actually is, because it's not like a deformation in any kind of space-time. Gravity is like the electrostatic dipole effect, which is created by ordinary spin forces. That's why these, it's the first cousin to gyroscopic force, which is why these gyroscopic experiments work. You've got like, if you go on YouTube and just, it's not that hard to find. You can find these experiments where a guy will take a heavy steel bar and take a 40-pound wheel, okay, and this bar is like about 2 meters across. Hold it at one end. You can't possibly lift something like that over your head or even up off the ground with one hand. If they spin that wheel to like 4,000 RPM, it becomes easy to lift with one hand.
What causes the spin?
Well, a drill. They're just connected to a drill and spinning it up at that kind of speed.
Yeah, but what powers the drill?
Electricity. No, I'm sorry, we're talking about simple things, right?
Where does the electricity come from?
Uh,
Because electricity by itself it's the potential difference.
no, you're asking meaningless questions. I'm sorry. It's like electricity comes from local power
That's
companies.
right.
Like,
What, I mean, you gotta have a.
No, you're saying that if I have a gyroscope on the end of the stick.
You cannot start with what Einstein, Einstein described gravity as being some kind of four-dimensional differential geometry thing. You cannot start with that and believe that it ever could have been attenuated like 3, 4, 5 to 1 in very recent geological times. Nonetheless, it's a very easy demonstration that it has been. Okay, and that a large dinosaur would simply be crushed by his own weight in our present gravity. They never experienced gravity like we do at all. Okay, and this has to do with this different explanation for gravity that I'm talking about. Look, it's like.
What were you saying about the dinosaur?
Okay.
Squashing itself.
You might remember that it was always the littlest kid in your classroom because you did the most push-ups and the most pull-ups or any kind of ratio exercise in school. That's because of what you call a square cube problem. It's like weight is proportional to volume, which is a cube figure. Strength is proportional to cross-section of bones and muscles, which is a square figure, like or squared. If you double your physical dimensions, if you go to sleep at night, you're 5'5", you wake up in the morning, you're 10'10", well, you've got a factor of 2 that just got figured 3 times for volume and weight, 2, 4, age could be 8 times heavier. You're only going to be 4 times stronger. You'll cut your power weight ratio in half. You can obviously only cut your power weight ratio in half so many times to still stand up and walk. Okay? Now, for the very strongest human athletes that we know anything about on the planet, the point at which that square cube problem stops them from standing up is going to be about 18 or 20,000 pounds. That's the mathematical limit for size for the world for any kind of animal, okay, that needs to stand up and walk or do anything at all on our planet. Now, the biggest elephant.
So what, are you saying that the dinosaurs were in existence?
The big ones would be crushed by their own weight in our present world. That's the fact.
Well, so you say the world acted under different constraints?
Gravitation.
I'm telling you, gravity, like
at
3 or 4,000, even 3, 4, 5,000 years ago, gravity was a fraction of what it is now. Okay, and it had to do with the surface charge of the Earth, with the fact that surface charge was damping this electrostatic dipole effect.
Is that something accepted by scientists generally, or is that something?
No, it's not accepted by scientists generally just yet, but it will be 20, 30, 40 years from now.
Okay, where did you discover those?
Okay, I'm the first person to ever put numbers on this sort of a thing. This was featured on a program which was shown on primetime television in Japan in 2004, right? I mean, it was an interview with myself, interviews with a couple of other people in the United States that study these kinds of things, interviews also with Japanese scientists.
Okay, so the idea, first of all, is that
Okay.
gravity.
Let me talk about LIGO for a minute, because I'm sorry, I'm just
Hold on, I want to
No, she's got a question. Let her ask her question.
Go ahead.
You're opposing what he's saying, but I'm still not understanding what
Yes.
are you opposing the existence of gravity?
No, I'm opposing this entire idea of gravity being some kind of four-dimensional geometric thing.
And are you saying that it acts instantaneously?
Gravity does act instantaneously. We see the sun where it was from 8 minutes ago. The gravitational force we feel from the sun is instantaneous, real time. It's from where it is now. Okay,
Well, how do you explain?
There's no 8-second delay.
How do you explain the fact that we have now a way of measuring the distance to galaxies using what's called a standard candle, where you have a supernova, type A supernova, that you can use the luminosity of that supernova to discover the distance to distant galaxies?
Okay, I'm sorry, I'm not following that.
Infrared, how bright
Is that, do you know why the gravitational field decreases by square
Yes, I
distance?
do.
Why?
Basically, like I say, this gets back to Ralph Sansbury and his experiments with what you call sub-electron particles, or subtron. Okay, and this started off with a very mundane kind of a thing. This didn't start off with some kind of a back-of-the-book search for an answer to gravity. It started off with a very mundane kind of an investigation of currents creating electrostatic fields, which should not happen, but it does, right? Now, basically what Sansbury discovered was that, when you run a current through a wire, it creates an electrostatic field which reverses when you reverse the current. That seems reasonable enough. There's only one way to explain it, okay? And it's like electrons normally are not, thought of as point particles, the way an atom was thought of 150 years ago. Now, there's no such thing as a point particle in real life. It's like Sansbury basically noted that if an electron was a point particle, but it would not have it would not ever represent a
Yeah, but how
dipole.
does that create gravity?
Let me start off talking about like electrostatic fields for a moment, then I'll get to gravity. Okay, basically, what he said was that like it seems obvious enough that electron itself, or a proton for that matter, has to be like a small orbit. It's not like one particle; it's a small orbiting system of its own, consisting minimally of a central particle and one orbiting particle. The charges of which sum to the charge of an electron in the case of an electron. Okay, he said that normally at rest, an electron like that is not going to represent a dipole, but when you subject it to some kind of force, which in the case of this wire is a voltage, then it will. Not only will it begin to represent a dipole, but it's like all the electrons in that wire are going to represent dipoles which are aligned in the same direction, right? So in other words, that is going to create an electrostatic field transverse to the wire, and it will from here to the Andromeda galaxy like in 1 or 2 seconds.
So that violates the speed.
Yeah, that's right. It says Einstein was completely wrong in trying to claim that nothing moves faster than the speed. Let me tell you something else. Gravity is known, and this has been known for 2 or 3 centuries, that gravity propagates instantaneously.
That was Newton's idea. That was refuted.
That's a fact, okay? And this is, you can look at Tom Van Flandern. Tom Van Flandern was like one of the world's leading experts in this.
Who?
Tom Van Flandern was the director of the U.S. Naval Observatory, which is in the same building as the vice president's abode in Washington, D.C. on Mass Avenue, upper northwest Washington, D.C. Now, Tom Van Flandern still has a website, which his family maintains. He died about 4 or 5 years ago. It's called metaresearch.org. You can find it, right? And he has one whole page of this, which is devoted to the speed of gravity and what the actual experiments say. They all say the same thing.
But what you're talking about is Newtonians who have been
That's correct. Look,
right.
The solar system,
refuted.
the solar system would fly apart within a few days or a few weeks if the speed of light was, or if gravity was propagating at the speed of light.
That the speed of light could actually be.
If gravity did not propagate instantaneously, our solar system would not hold together. That's been known.
By who?
Yeah.
Pretty much the whole world.
So wait a second, Ted, so you're saying that when Einstein got his Nobel Prize, the person,
Einstein never got any kind of a Nobel Prize for relativity.
I told you at the beginning it was for the photoelectric effect.
Einstein was trying to account for what they assumed to be the failure of the Michelson-Morley experiment with deformable time. Okay, now that's a long story in itself.
No, it's a very short story.
There are 2 problems with that at least. Okay,
Hold on.
Let him rebuttal.
The Michelson, it's similar to the LIGO. Is that if you have the Earth is orbiting the sun at 66,000 miles an hour.
Yeah.
And what they used before they had all these fancy lasers is they had a beam splitter, and they had a right angle experiment. They had one facing the direction of the speed of the Earth and the other at right angles. And they looked for a difference in interference pattern.
And they send the light through, right?
Look, you've got 2 deconstructions of this thing.
Hold on. Let him finish. Go ahead.
Yeah, so what you had in that experiment is the proof that that the speed of light does not depend on the speed of the observer, that the speed is constant, that the speed of the light going with the speed of the Earth as opposed to perpendicular to it is the same, because when the interference pattern was observed, it was a null result.
Look.
So you dispute that?
Yes, I do. Okay.
Oh, you dispute that the inertia of an object depends on its energy content.
Look, David Miller was one of the best physicists of the era after Einstein, Dayton Miller.
Oh, Dayton Miller.
Okay, who
Yeah, we had him in the
Yeah,
21st century.
Okay, Dayton Miller reran the Michelson-Morley experiment with better equipment and a higher altitude to reduce any effect of gravitational drag on the ether, and the experiment did not fail. That's one problem with Einstein's analysis. The other problem is that even if you were to assume the Michelson-Morley experiment had failed and that there was no such thing as an ether, and that the speed of light was constant to within our ability to measure it, then there are at least two better ways of explaining that than to believe in deformable time or deformable space or anything like that. Okay, let me tell you a little bit about this LIGO experiment, because this is like, you know, when you talk about light year, I don't think most people will have any kind of a gut feeling for it. It's like, if you scale our system to be like, you know, 1 meter in radius, you know, so the sun is here and it's like Pluto is out here about a yard away, right? Then at that scale, the sun is the width of a human hair, the Earth is 1.5 inches or so away from the sun, and the nearest other main sequence star like ours is 4 miles out yonder, right? And that's Alpha Centauri. Our own galaxy is about 100,000 light years across, and you're trying to claim that something like 1.3 billion light years away actually caused a mirror to move like about 4/1000ths of the diameter of a proton. If I was a farmer and had a chicken or a pig that believed something like that, I'd take them out behind the barn and shoot him through the head. I wouldn't tolerate it.
Well, you know better than Einstein, than
Look,
LaRouche, and the Chinese scientists.
He would not.
For associating his name with something like that. Okay, you've got two major deconstructions of this whole thing. I don't think it's going to last more than a couple of weeks yet. Like another claim of gravity waves being seen like in 2014, it's only lasted about a month, right? And that was this bicep 2 thing. And I think these guys are going to catch so much.
That was because of the polarization.
I think these guys are going to catch so much heat for this thing, it'll be retracted within a couple of weeks or a month.
I don't think so.
Okay.
But by the way,
Well,
brought by Whitney, if there's anybody that wants some sheets.
Thank you.
over here.
So, hold on.
Well, it's like basically, when you talk about 1/4 the diameter of a proton, then it's like what Miles Mathis says, you know, that they haven't seen the mirror move, they've seen movement and one of the electrons in the mirror. It's the whole wrong scale. You know, they're trying to claim that like something's moving like that. You know, and it's like, you know, the whole level of scale is wrong for trying to make a claim like
But think
that.
about it, that's why what he said at the end about the investigations of, I mean, what China is going to be doing, and
They're
India
going to be wasting money
and
just like we are.
other countries to.
it's better
actually-
than blowing yourself up. Huh?
Yeah, right, exactly. To investigate further what this actual discovery is. The thing about it is that
It's some
we
kind of
made
signal
this
within our own
investigation from a
system.
ground-based observation. They can even go further to make an investigation.
Okay,
from
what they saw was a
space-based
signal coming from within the Earth, or within our own system, or at the very most from within our own galaxy, that they didn't discover. You know, they make it sound as if they had some kind of an instrument that saw this signal and then saw something out in the sky and associated the two automatically or something when they push the button.
That's not what they're saying.
No, I know, that's what the average person is going to get reading it, right? It's like,
Well,
that's what I'm
the
saying.
Well,
Ted,
did you read did you read the report?
Yeah. Yeah, I regard it as garbage. I'm
Well, then-
serious.
You took that attitude into the report, so that was your natural.
It's what you expect.
That's what you wanted, so that's what you read.
Ted, can you re-examine your assumptions?
I mean, for those of us who are laymen, and, I mean, you know, this is way above my head. I feel like I could benefit, Ted, if you wanted to give some kind of talk where you prepare data and you, on a sheet of paper, because what's going on is you're jumping around with different ideas.
Well, I'm sorry, I just have to listen to like about 40 minutes worth of this, and it's like,
Well, I know, but for those of us who
Yeah.
are laymen, I mean, when you jump around, we can't catch every little thing you're saying.
Mhm.
And it's lost on me. I mean, if you started from point A and then said, okay, the first thing that Joel said I disagree with is this thing because da-da-da-da-da. And here's an authority who would
but they're not even
support
talking
that.
about like,
The second thing that Joel said, you know, but you're jumping around so much, it's like, I'm like totally lost. I mean, I was having enough trouble just trying to grasp Joel's ideas And then when you come and say, I totally disagree with Joel's ideas, I'm like, wait a second, which
It's all
idea?
right to disagree, you just have to have the evidence.
Now,
Can I ask a question?
Okay,
Joel?
yeah.
Okay, hold on,
Yeah.
I have a question.
Ask a question.
Yes,
This LIGO, who financed this?
National Science Foundation,
Is that a government program?
U.S. taxpayers, yes.
Oh, yeah. And that,
And the lead university in Louisiana State University in Livingston took care of their part of the experiment.
uh-huh.
The Washington State in Hanford, it was actually run by the California Institute of Technology from Pasadena, California.
Uh-huh.
And if you look at the end of the report, you have over 100 universities
Yeah.
from Russia, China, Brazil, United States.
And the Europeans, you've got the whole European Space Agency, ELISA. And, They're supposed to launch a probe in 2034.
For the space antenna.
Space antenna.
And why is it that the whole world right now sees this as a breakthrough for, the need to investigate, build new satellite systems, build new observatories, space and ground-based, and and then you have an opposition to that.
Well, now every experiment of general relativity from 1915 to today has proven Einstein was correct. That doesn't mean that it's a complete theory, because we have to discover more.
Right.
But if you look at the bending of light, if you look at the speed of light, they had an experiment with neutrinos a couple years ago saying, oh, these neutrinos arrived at the detector faster than the speed of light. And we looked at the equipment, and then they had a bad connection. So to say that the speed of light can be violated without proof is to say that we can go back in time. It's believing magic.
Okay, basically the description of gravity that Ralph Stansbury offers is that, you've got these same kinds of electrons which are essentially orbital systems of their own, just like an atom is, only on a much smaller scale. Which in the case of the wire and the electrostatic fields which are created by the circuit are stretched into dipoles which are linearly aligned, polarized basically. In the case of something which is spinning like a ball or a gyroscope or a planet, then these things are being radially aligned. Okay, now when you do that, then the electrostatic forces themselves integrate to what we call gravity, and the mathematics for that works. Okay, now you can get on Amazon.com, just type in Ralph Stansbury, S-A-N-S-B-U-R-Y. Okay, this is the version of gravity which Thunderbolts and the EU groups subscribe to, which I subscribe to. This also says that gravity is a first cousin to gyroscopic force, and also to the force that makes a tennis ball or a ping pong ball or a baseball
What you
Oh,
turn
subscribe to, it's like saying you subscribe to the.
in the air. Well, like because of spin. Right? Now, like I said, this will account for having creatures on the Earth which weighed 180 tons in the very recent past. Whereas anything like that would be crushed.
But that's the Flintstone view of history. That dinosaurs.
You don't have a way of okay, with this vision of gravity that you espouse, you do not have a way of accounting for those kinds of creatures on the Earth. I do. Okay, that's the difference.
Why are you saying that?
A creature like that would be crushed by its own weight in our present world. There's a mathematical limit of about 18 or 20,000 pounds. The actual limit is about 15,000. The largest elephants in our world right now are about 14 or 15,000 pounds, and that's like 1% of elephants. Any bigger than that, they wouldn't be able to stand up. Okay?
Well,
I mean, you can get that. You can get that limit just by taking a maximum possible weightlifting event, like one of our super power lifters. Like
yeah, but you see, you're stuck in your senses.
I'm sorry?
you're stuck in your.
I'm stuck in the real world.
Well, they see what is the real world. Now, if I were to tell you 100 years ago that I could use a piece of quartz that can communicate to anyone on the planet and that can read any newspaper in the world, that can have more memory than the entire Apollo program had in just my hand. This would be magic. There's no physical explanation. All of these devices are the result of the breakthroughs made 100 years ago by Einstein and Planck. And what we've done is we refined those discoveries with new technologies. So the photoelectric
way of explaining dinosaurs. I'm
talking about
it doesn't matter.
Something in your hand. You can't explain to me why this works by talking about dinosaurs.
I can explain why Einstein's theory of gravity doesn't work.
How do we know how much a dinosaur weighs?
I'm sorry?
How do we know how much a dinosaur weighs?
Just simple volumetric analysis, right? I mean, you could simply make, we know how much elephants weigh, and you can make scale models of a large dinosaur.
Wait. We don't know 63 million years ago what the biological character of those animals were. They could have been a hell of a lot lighter than elephants for cubic
It's like, meat weighs the same now.
Well, why not? Why couldn't it change?
If you're saying gravity had changed, that there was a different gravitational force working on, but why couldn't there also
Gravity
be?
was heavily attenuated, and I'm telling you, it was attenuated by electrostatic forces, which is basically the surface charge of the Earth.
How does that explain the strong force of the nucleus?
I'm sorry?
How does that explain the strong force of the nucleus?
I don't know that it does. Okay, I mean, I've never even bothered with. I'm not a physicist. Okay, it's like my training in schools like in languages and mathematics.
Okay, so I took 4 years of physics.
Okay.
I studied electricity. I'm an electrical engineer by training. And what you claim to be gravity is fiction.
You don't have an explanation for dinosaurs. They used to believe that, like engineers like 120 years ago used to believe that dinosaurs lived in water.
You don't have an
Because they knew they couldn't
explanation.
sport all the way on land, but it turns out they had no adaptation for life in water. They would have needed snowshoe type feet. The feet they had would just go straight in and then
It's like one of these debates that you just lost.
You don't believe that they existed 66 million years ago.
They're getting good radiocarbon dates of dinosaur remains now. The dates all come in 20 to 40,000.
Yeah, but carbon dating, you know what the half-life of carbon-14 is?
That's right. It says they didn't die 60 million years ago. They died like 20, 30, 40, 50, 60,000 years ago. Somewhere in there. The dates they're getting all come within a range of 20 to 40,000 years.
Wait, what,
I'm sorry?
Can I ask Joel, what was your point about the half-life, the carbon dating? What's the point?
Carbon dating, the way you do carbon dating, and by the way, E-harmony was going to merge with carbonite to improve the carbon dating.
Okay.
But what you do with carbon dating, you see, you're 18% carbon in your body, and you're 60% water. Yeah, we're going to eliminate that at Paris.
Okay, nothing more than 60,000 years
Wait,
old.
let me explain the carbon dating. Is that as you live and eat and breathe, you're taking in carbon from the environment.
Mm-hmm.
Now, most carbon is carbon-12. That's 6 protons and 6 neutrons for a total of 12. There is a radioactive isotope of carbon which has 2 extra neutrons. So instead of 6 neutrons and 6 protons, it has 6 protons and 8 neutrons. Now, because of these extra neutrons, it is not stable, that it will decay. So if you have 10 pounds of pure carbon-14, after 5,000 years, that chunk of carbon will have half of its weight left as carbon. The other would decay to nitrogen or some other element. So using that decay rate, if you find a body, like they just found the body in the Alps, you probably heard of the Iceman of Italy. They just had a nova on this last week. They found this body coming, these hikers were up in the Alps and they found this body with sandals and hay and shoes and quivers and an arrow. It turns out this guy was a hunter from 5,000 years ago. How did they determine his age? They look at a tissue and they look at how much carbon-14 is left in his tissue, so that when he died, he no longer was taking in carbon-14 or any carbon. So whatever he had would decay and not be replaced by new carbon-14s. So that if, in proportion to the rest of his body, if the carbon-14 in this person's body is half of what it is today in a person's body, then you can determine the age of that body. And they determined his age is 5,000. However, because every 5,000 years you get less and less of that carbon-14, to determine something that's millions of years old, you use different elements.
If you find something that radiocarbon dates 20 or 40,000 years, then you give up on the idea of whatever was being 65 million years old. That's the honest approach. Anything else is dishonest.
Okay, well, so where is the evidence that dinosaurs have been carbon dated to 20,000 years ago?
I'll send it to you. Well, I'll send it to Kesha. If I send that to you, could you get it?
Yeah,
Okay.
yeah, I can read it.
Because that's well known. It's like they're finding soft tissue in dinosaur remains, which includes skin cells, blood, hemoglobin, collagen, which includes blood vessels, includes every kind of thing. And this has been turning up since about 2006. They never thought to investigate dinosaurs for soft tissue previously because they always had this quasi-religious belief that the things died 65 million years ago. And nothing like that would last more than a couple of times.
But what does carbon dating have to do with gravitation waves?
We're talking about the age of dinosaurs now, like, when they actually died out. It's like you've got recognizable pictures of known dinosaur types on American Indian petroglyphs on canyon walls in North America.
Well, one thing I think is,
I'm sorry.
go ahead, finish that thought.
You've got
what you were saying.
Accurate descriptions of dinosaurs, like in American Indian oral traditions right now. A friend of mine who died about 5 or 6 years ago was the best known of all Native American authors, Vine DeLorean, right? So president of the National Council of American Indians twice, 3 times, I don't know, but he has a book which is called, he has several books which are standard textbooks on Indian affairs. Custer died for your sins, right? That's common. Okay, he has another book which most people are less familiar with, which is called Red Earth, White Lies, which is generally a deconstruction of the idea of native ancestors, killing out the megafauna like 12,000 years ago in North America. But he has one chapter in that book which talks about dinosaurs in American Indian oral traditions. And he attended one of these Cronia conferences in
Hold on 1 second, because you're going off.
Okay.
So,
he told me at one of these conferences, he wanted to hear my little talk about dinosaurs and gravity. Okay, now, he told me that he had been compiling a kind of a large book of American Indian oral traditions, and had been talking to every storyteller and every keeper of oral traditions all the way from, Alaska down to Tierra del Fuego, right? And he said there was only one thing that used to throw him off, and was the extent to which 80% of these stories involved dealing with dinosaurs, within like the last 6, 8, 10,000 years, right? They oral traditions, some of them are that old. And he said that at first he thought these people were jerking, right? I mean, he said that, but it began to dawn on him, that were the case, that knowing Indians the way he did. He said that the way these legends would read would be like, the Indian brave killing some kind of monster with a spear. So they never read like that. They always like building log stockades to keep the idiots from trapping the village.
okay,
But these are myths, though.
Yeah.
Although, because of the LIGO experiment, I discovered what's in a black hole.
Oh, yeah?
Changed.
Okay, dollars. So there's no such thing as a black
Paradigm.
hole.
What is it?
It's a new paradigm.
A paradigm. Can you explain, for those of us who are not that clear on black holes, the two things I was thinking, one is, can you give us an understanding of black holes better? And then the other one is, what is the significance of the fact that the thing is a right angle? You know, does that right angle thing, is that how it balances? I mean, I don't understand why the.
Well, first with the right angle is that if you have a disturbance coming through Earth, that one part of your apparatus will increase because the wave is disturbing the length of your arm. So that one length will increase while the other decreases. So, like the Egyptian.
Okay.
So that using the beam splitter, if there's no change in length, then there's no interference pattern from your
And the beam split stops that from happening? The beam split?
No, you're just using the light to measure the distance. So that if this table is moved by a wave, a gravitational wave, then the length will change in one direction. The width will change in a different direction. Will be compressed. So you're looking for that change in length and change in width. And when you recombine the beam, if there's no change, then you get the no result. If there's a little bit of change, you get an interference pattern.
And the interference pattern
Tells you the difference.
And it indicates to you that what is happening, that there is
some kind of disturbance
coming through, like a planet, like a star, like a
well, far smaller,
or something smaller. Okay.
Right. What they're calling a gravitational wave. But getting to the source of the wave, what they're saying, a black hole on Earth, you have a gravitational field where if I drop something, it accelerates at 32 feet per second squared, no matter what it is. And on the moon, you have a different gravitational field. And when the astronauts were on the moon, they did this experiment where they dropped a hammer and a feather to see which you think landed first.
You guessed the hammer.
But they both.
They landed at the
They both
same
landed at the
time.
same time.
They landed at the same time because the acceleration is the same, no matter what your mass.
But that's not true on Earth.
Yes, well, the difference is Earth has air, so there's air resistance.
And the feather catches the air. I see.
Right, so if there's a vacuum, like the moon,
Yeah, there's a vacuum.
almost a vacuum, then the feather drops the same acceleration as the hammer. Now, what they call it, what Schwarzschild, who's a colleague of Einstein, said is that if you have a mass that is so massive that its acceleration is greater than the speed of light. In other words, that you have so much mass in such a small area that light cannot escape. That to get off the planet, I have to reach, to get to orbit on Earth, I have to reach 17,500 miles an hour to get to orbit. To escape the Earth, I have to reach 25,000 miles an hour. That's why you can't just jump off the planet. Now, what they're calling the black hole is a region in space that is so massive that its gravitational field or the curvature of that space-time is so great that light can't escape. That even though light goes at 300 million meters a second, it's not fast enough to escape that gravitational field. Since light can't escape, you can't see anything. So it's a region that you can say it's a black region.
I would think on the contrary, light can't escape, and it's all well lit because the light stays there. I mean, I don't know.
But you can't see it because it doesn't reach the rim.
It doesn't reach the rim.
You think of gravity as a well.
Huh.
You're in a well, and it takes energy to get out of the well.
Mm-hmm. Right.
Now, if you have a flashlight and it's dark now, you can shoot that light.
Sure.
You can see the light from the well.
Right. The top
If
of
the well is so deep and the curvature of that space is so
powerful
curved that if you showed a flashlight or a laser, the light would go up
and turn back around.
and then come back. It couldn't escape.
Couldn't escape.
So you wouldn't see any light.
Huh.
Now what happens is that what they call solar black holes is that if you have the sun fusing the atoms in its core, it provides an outward pressure, energy pressure. If you use up that fuel, that hydrogen, then it starts fusing helium. After helium, you get oxygen, carbon. If your star is more than, say, 10 times the mass of the sun, it'll continue fusing until you get to iron. In iron, it takes more energy to fuse iron than what you get when you fuse it. So the fusion engine shuts down. So that what you have is a balance between the gravitational pulling in and the fusion going out. If your fusion stops, then all you have is gravity pulling the elements closer and closer together. And what Schwarzschild figured out is that it would condense to a point in space or a region in space where no light would be able to escape. But if you have dust around the rim of that region or that well, it would start like a toilet, flushing in, being sucked in. As you pull the dust into that hole, the region around that hole gets hotter and hotter because the gas is being squeezed and squeezed. And when you squeeze gas, you can produce radio waves, X-rays, gamma rays, depending on what kind of dust. So that you can see the effect of a black hole by what's going on around its rim, or what they call the event horizon.
And when you say black holes, you're not talking about voids of empty nothingness. It's as substance with the
It's,
right, there is something there. And
Yeah.
what Ben has gone through is that every galaxy that we know of, there's a region in the center of that galaxy where you have stars that are orbiting that region. You look in the visible light and you can't see anything. But you see a star near that region and it's going fast.
Huh, almost like something going down a drain.
Right.
Getting ready to.
There would be some other explanation. But Joe, listen, there's two other kinds of things that you could not have with
Why would there be some other explanation?
I mean, I would have to send that to us. It's a long story, but it's like, there's two other kinds of things which you couldn't explain with that sort of theory of gravity. One would be, like Dejean put Pletnev's experiments in the 1990s, okay, and he's gotten to be very difficult to talk to now. I mean,
what's his last name?
Pletnev. Okay, and he spells his first name Eugene rather than Yevgeny. Okay, he's Russian. Okay, he's associated with one of the big universities in Finland. Okay, he was doing experiments which reduced gravity, using spinning superconductors. Now, if gravity is a four-dimensional differential geometry thing, you can't reduce it right now. There's also an acronym which is called GRASP, which stands for Gravity Reduction Advanced Space Propulsion. And you've got American flag officers involved in this, and this is a real U.S. government project, and it wouldn't be such a thing if gravity was the way you describe it. You see, one of the neat things about the U.S. military is that they don't have the luxury of worrying about whose science fair teams they step on, right? And you've also got this question of the way that the wing on the B-2 operates, the stealth bomber, okay, what they call the brown leaf belts.
Batwing.
Batwing.
The wing, the leading edge of the wing on the B-2, they say that once the thing gets to altitude and speed, it requires no further fuel, it can just stay up there forever. That's what I've read.
Yeah, but these guys are promoting, they're promoting Newtonian views. They're just going from the standpoint of a.
Yeah, Isaac Newton was a pretty bright guy.
Pretty right.
He was a fraud. He claimed to have invented the calculus. And have you read any of Leibniz?
Leibniz and Newton pretty much came to the calculus at roughly the same time as I read it now. Leibniz invented was the dy/dx notation to make it look as if you were simply multiplying fractions together when you compose function. When you take derivatives for a composed function. Now, he thought that his students weren't bright enough to do that without some kind of a simple mind game like that. So, Isaac Newton didn't require anything like that apparently.
Well, he believed that we had absolute space, and the time was like a set clock, uniform time.
It works for me.
No.
Because you're stuck with your senses.
Like I said, I call that living in the real world. I mean,
Well, you're saying
Yeah, but
physicists
how
who are
does that-
making
okay,
how does that
making
account for
discoveries
the
don't live in
hydrogen?
the real world?
like I say, I mean, you've got things out there which you can't account for with this idea of gravity being some kind of geometry thing.
So somebody develops a theory.
The biggest thing that you can't account for is the large dinosaurs. I mean,
But
they
the
can't be
dinosaurs,
made to work.
how many dinosaurs live on Jupiter?
I don't even
Jupiter is a
know.
gas giant planet.
I don't understand. How did the dinosaurs, so you're saying,
The existence of these kinds of animals, look, it's not just
Oh, you're saying they
dinosaurs.
didn't
You
exist?
say that
The
gravity
heaviest-
changes.
The heaviest thing that can fly in our present world is about 25 pounds. An albatross or Berkut eagle, and that would be like an exceptionally large.
What are you
bird.
talking about? A B-2 is more than
I
25.
was gonna say, what about an
Okay.
airplane?
I mean, a very short distance ago, you had birds with 25-foot wingspans weighing 200 pounds that flew. You had flying creatures with a 60-foot wingspan that weighed 1,000 pounds and they flew. That can't happen in today's world. It's the same square cube problem. Weight is proportional to volume. Your ability to fly is going to be limited by surface area of wings, which is another squared figure. Volume is a cubed figure. You've
So
got
you're
the
saying
same-
these flying dinosaurs?
would not be, okay, the birds that we have, which are larger than 30 pounds in our present world, adapted by having the wings become vestigial. There's no flying bird more than about 30 pounds in our present world.
Okay.
So
might
you're
get a
saying
bird.
that gravity has changed? That
Yes.
it wasn't 32 feet per second squared?
No, what? Okay, like I said, this is because gravity is an electrostatic dipole effect. It's not a four-dimensional differential geometry thing.
Well, your definition of gravity is
That's
different.
I mean, Albert Einstein was simply wrong about that. I think I wasn't on mission.
So Newton was right, but Einstein was wrong.
Yeah, right.
Well,
Well, I thought we
I don't
only
think
just
gra-
proved Newton.
Isaac Newton never tried to say what gravity was, okay? Hold on. Isaac Newton just said, hey, this is the way gravity works. He didn't say like, hey, I know what gravity is, right? That's,
Yeah, but if you accept Newton, even if you accept Newton,
okay. The
where
version
in
that I
Newton's
accept-
formula does it allow for a change in gravity?
I'm sorry?
Where in Newton's formula does it allow for a change in the gravitational constant?
He never got into that. Like I said, he was trying to tell people how gravity worked under present condition. That's all he was trying to do. He wasn't trying to tell anybody he was God or Jesus Christ or anything like that. He was
Neither
saying,
Did
hey,
he was trying to tell people when the end
Trying
time
to tell us
was.
he's God.
well, what?
Newton, did you ever see his chest was opened by Keynes back in the 20s?
Right, okay, yeah.
And he believed in, he was an alchemist.
What else has changed to cause it?
I'm sorry, well, start that over again.
If gravity has changed, what else has changed to cause the change in gravity?
The collapse of the electrostatic field of the Earth, okay, it's like, you used to have as much static electricity as you see in our world today. There was a whole lot more like 2, 3, 4, 5,000 years ago. It's like you have those pyramids, which were essentially, they were light devices. I mean, they had golden tips and then they glowed permanently. It's like what you call St. Elmo's fire. The plasma physics phenomena. Okay, it's like the nature of the solar system itself has changed.
And this electrostatic effect is not just working on its own. It's not something.
It's a long story. If you want the whole history of the solar system, I can give it to you, but I need at least another 20 minutes.
But I was gonna ask Joel, what did they find in his chest that was so interesting?
Oh, that not only was he an alchemist, he
Meaning,
believed that you could by magic formula you can change lead into gold, mercury into gold.
mhm,
Now we can do it today.
Yeah.
With nuclear physics.
Mhm.
We can transmute elements,
mhm.
but you can't do it with magic. And Newton was looking at the Bible, figuring out to the day when the end times was coming.
Did he have a date?
It's coming soon. You have
If we don't get Obama out,
It's coming a lot sooner than-
Coming sooner.
I think we all agree on that.
Now, you talk about carbon-14, I know this is a little off the subject of your initial talk, but is carbon-14 just in all of us? There's a certain percentage of carbon-14
As long as
floating
it's-
around in the
as long
air?
as you're
As
eating.
long as you're living, you take it into your body.
You're
Okay, it's
taking
like
it
when you
constantly.
die.
That's when you stop
the
taking in
radioactive
new
isotope,
carbon-14.
From the radioactive isotope start to decay. And after 60,000 years, there'll be nothing of it left. Okay, so the extreme limit for radiocarbon dating something is about 60 to 65,000 years. Anything more than 60,000 years old will not radiocarbon date. Therefore, the fact that they're getting good and multiple radiocarbon dates for dinosaur remains at this point says that this whole thing that we've heard all our lives about dinosaurs dying out 65 million years ago is a bunch of BS. That's reality.
Well,
So you don't believe in the asteroids?
No. Well, yes
Or
and
that
no.
the
I'm sorry.
Earth-
When you're talking about what killed off the dinosaurs, then you've got a mixed bag. Okay, it's like I figured most of them were killed off in catastrophes, which were bigger catastrophes than an asteroid would cause. But the fact that none of them left at all. I
But
think
how
is
did man survive these catastrophes?
mostly hiding out in caves and underground areas. They're finding like a whole system of tunnels underneath most of Europe. They're finding cities underneath the ground, like in Anatolia and eastern Turkey, right? And they've got a city which is called Dejean, which would support 30,000 people, which is completely underground, like about 6 or 10 levels.
What was their energy source?
I'm sorry?
What was their energy source underground?
Nobody knows how this thing was created. I believe it was created to survive the ice age, the last couple of ice ages, major ice ages. Okay. It wouldn't, something like that. You see, they don't have a way of dating that. And I've read a number of articles on this. It's like, you know, some people believe that it was built, you know, like as a hedge against invasion or something like that. But somebody like Sargon or like, you know, if it was built to protect you from Huns or Mongols or something like one of Genghis Khan's employees would just
This is
pour
in
naphtha
Turkey?
down and breathe a whole line of match, right? And it wouldn't work.
He said, was it in Turkey?
This was in Turkey.
Anatolia, yeah.
If that was true, Erdogan would be saying, you see, Turkey is the root of civilization. And he would be
I think you pronounce the guy's name Erdogan.
Erdogan.
Yeah. Okay, it's like,
But he would be claiming that
Here's
Turkey
what-
is the root of
well, this place
civilization.
is called Dejean. You can look it up. It's not a mystery. It's not something you can't find. Derinkuyu. Okay, Dejean. Okay, it's a city which would support 30,000 people underneath the ground. And it has to have been, the only thing that I know of that's ever happened on the earth that something like that would get built for would be the last couple of ice ages. Okay, the same thing is true of these tunnels that they have going all the way from North Scotland down to Hungary. We've got a whole network of tunnels going.
That's the Channel Tunnel.
I'm sorry?
They just finished that in 1994.
No,
The
I'm
Channel
talking about the tunnel. You're talking about one little tunnel going from England to France.
Yeah,
You're
this
talking
is
about
something
something
from
underneath
France.
most of Europe. Okay,
And that's on the
So-
web, that's
It's called humor.
Derinkuyu is something you can look up on the web, yeah. That's an easy thing to find, it's like you type in Wikipedia, Derinkuyu.
You didn't stay off that web all night.
You gotta start reading Leibniz.
And Kepler.
I don't know what it takes to, I'm not volunteering to go to Turkey right now. I wouldn't advise it, okay?
Well,
Yeah, but don't you think Erdogan would be proud of such a thing?
Is this like catacombs or? These tell us your.
This is, you've got more than one city like that underneath the ground in Anatolia. You've got a number of them. Okay, the biggest and most well-known is called Dejean.
Uh-huh.
Okay, it was made, as far as I'm
And it's
concerned,
still, it's maintained now, I mean, it's.
it's still in really good shape. It has like, breather holes, and it's got like rooms and things which you might call little chapels and living rooms and apartments. You got as well. The best estimates that I've seen say that it would support 30,000.
And the archaeologists, when did the archaeologists discover this place?
I believe this is somewhere in the 1950s or 60s.
So-
It wasn't an archaeologist who discovered it, some guy digging in his
He
backyard.
was digging his backyard, he found it.
Yeah.
Huh.
That's the way a lot of archaeological stuff gets found. I mean, it was like,
Yeah, but 30,000 people, you need some kind of energy source for cooking.
I don't know. I mean, I haven't been there, and it's like, I would guess probably either wood or coal or like some kind of thing, or it could even have been petroleum. Who knows?
Okay, Ted, when's the last time you read Leibniz or Kepler?
Why?
Because that's what we got to discover.
I'm lost in what?
We're trying to figure out Leibniz ideas, Kepler's ideas.
Against Newton.
Okay, Leibniz's ideas.
And Einstein.
Okay, fall into categories. Leibniz's ideas include like international trade, international.
No,
Scholars.
he had ideas about the universe.
He actually.
He had ideas about calculus, right?
No, he
about-
actually-
And the steam engine,
and that-
And also-
and the cat theory.
Physical economics, he was the first to really put together this idea of economics as a system of discovery and the heat-powered machine, and I mean, the idea of physical economics, one of the reasons that Lyndon LaRouche, developed the thinking he did on economics was that as a boy, he had access to Leibniz. And
Of
read about those Leibniz.
the LaRouche group heroes, then the one that I could come close enough to viewing as a hero would be Leibniz. Okay?
Well, that's a start. That's a start. All right.
I've asked people that I associate with, to include some world-class scholars, like, have you ever heard of Nicholas Cusa? The answer is yes.
Oh.
I've also asked people that I consider to be, major scholars, like, have you ever heard of this guy Vernadsky? The answer is no. Okay.
It tells you something,
What
doesn't
do
it?
you
Ask people what they think of Lyndon LaRouche. I mean,
They'll say, I
Well, I
don't
get all kinds of opinions on that one because
Yeah.
he's recent enough, right?
yeah,
I
he's
mean,
still alive.
this is a
Still
lot.
current.
Right,
They've done
right, right.
everything to ostracize
Right.
him.
yeah.
And you can see why today.
The two people that I regard as the supreme scholars of the last 100 years are going to be Manuel Velikovsky, number one, and then Julian James, number two. And I think that if you had to have two books in your hands to try to understand, like, the history of the world, the history of the human race, I think it's going to be those two primary books, going to be World's Inflation and then The Origin of Consciousness.
I haven't seen the effects of them.
Well, what we're doing is we're making history. That's what.
Right.
Now everybody should know. Next Saturday is the meeting down at League City Library at 2, Helen Hall Library on West Walker.
What's the topic?
Well, it's
Give us
reviving
directions.
NASA. It'll be Kesha Rogers. It'll be Thomas Weissmuller, who is an alumni of NASA. He's a meteorologist who was laid off in the first layoffs, but he's one of the top experts who goes around all over the world on the going after this climate change caused by man as a fraud. So he's,
And that's something that I'm definitely in the same.
of course, you should go to this. And then the third person is Megan Beats. And if anybody goes to our website and sees some of the science work on Wednesdays, which Megan is one of the science scholars with LaRouche, who's done a lot of work on Leibniz.
Okay, the science team of yours worked for me at Firehall.
Well, where were you?
I'm sorry.
I don't think they're paid. Most of us aren't really paid.
I had to do exactly what Donald Trump would do, say, you're fired. That was,
Okay, well,
Darren Dejean to you, D-E-R-I-N-K.
Hey, Joel, guess what? There's some chocolate in the room. Would you like some? Yes.
I want proof. I ain't gonna take your word on that one.
Peppermint.
Here's a cookie with chocolate on top, and this is nice to Whitney.
Roach, and then
Here
Oh,
you go, and then right underneath your hand. There's a whole plate of them.
oh, it's a whole plate.
Don't eat all of them.
So I'm gonna do that.
Hold on a second.
You'll get yourself sick.
And then there's some,
You know, speaking of Einstein,
this is Thin Mints from Betty. Right
you,
there.
you know, I tell you what his favorite dessert was.
Chocolate?
Oh, brownies.
Why?
You wrote a whole paper on brownie emotions.
Oh, stop.
Now, okay, so what is your, I mean,
Ask me,
why did you bring up this during?
he asked me like what might have changed that would cause dinosaurs to die out or, you
Now,
know,
why does the dinosaurs die out?
Did you ever hear about these?
and so you got some
I
kind
did.
of task.
No.
Walking up the
Well,
hill.
how do you know? Just because there's an.
It's not
the only thing we have to do.
Large masses
I mean, you could have an underground brother.
Yes.
fall
Because
into
you got one, you know,
That's
that's climbed down like 6 or 8 bucks.
Rather-
With the route.
It's an ancient multi-level.
They are,
And they got one,
you know,
I didn't know the test
Turtle
for
on standing to
not like
it. And it's got a big.
continuous.
These large, you have sheltered across. the-
It's especially keto.
Isn't that funny?
Creation.
So, yeah, I've read through
Space
it.
and
I know you
fabric
already.
is actually
But what do you think?
extension of these masses, which are contained energy in a form of matter, and being that it is
So that's interesting.
the cause of it is the fact.
So what
I was
your
gonna
thesis
suggest-
is that
Well, that's a simple
dinosaurs and
fact.
people lived at the same
That
time
is-
as each other.
Because you do have the sun.
And you're saying
And this is
that
where the, and
So we've got pictures of
Yeah.
dinosaurs
Yeah.
sized up on canyon walls, what they call petroglyphs.
you look at a
We've got
star.
one
E equals MC squared.
And I don't quite believe, I have my own version of what light is, okay? Which I call the
It
right.
means
already
that
light.
mass and energy are the same nature.
I believe that, right,
Okay,
series
so
of vowel
therefore,
waves
any
created
large
by
mass,
Sanskrit
the
describes.
the existence of that large mass in a locality is coherent with any energy that is somehow within its
So
field.
Sanskrit version
And
of light
the
is such that it's
mass is going to create the field in which that energy is moving around.
The accumulation
Moving through it or in it, or however it's, wherever it's coming from.
Okay.
And so, I'm just trying,
When you talk about gravity,
because I don't, when I started thinking
whether
about
Joel is right
mass
or I'm
and
right,
energy, where I
either
started
way,
thinking about
gravity is just
this idea
a
of
way.
the fabric of
What they're
space-time.
talking about
It's like you put
something involving
the
gravity between some kind of film like that,
container
you're
on
not creating
a towel and film
you're creating a wave and you're traveling
But I don't think space-time and mass, I don't think.
But you've got so many things,
They're
like
not-
I
they've got to be
said,
the
it's on the
same
so
thing.
microscopic signal, which
In
is so low.
different
What you're really looking at is not
configurations.
the mirror, but it's like
How
one
could
electron
mass
mirror
shape?
inside
So
the
it's
mirror.
Saturday, right?
Yeah.
If there's some way to rearrange your schedule, it'll be.
You're talking about something which is so far away that even a whole galaxy just look like the point of a
This
pin.
side is what is celestial.
I'm trying to make a claim that something happened in the galaxy, that's
From
all.
NASA.
That's what I'm trying to make a claim. Trying to make a claim. Look, I'm not gonna be, look,
Yeah.
this is garbage.
that's-
On time?
This is, this guy's gonna cut so much, this guy's gonna cut so much grief over this, this is gonna be.
Oh, okay. I
This
see.
is like, this is gonna go
That's
away.
why I'm using an hour later.
But I think it's so very easy.
Sometimes I can't do it all, but I got one last week that, yeah, I was probably one of the, she was there.
I was there.
I didn't see.
I was up on the stage.
And you know what it would also do?
I was singing.
And I played the piano at that.
Oh, wow.
It's the,
Why
the
did you have
these
the
terms
words?
that have been
Trying to surprise, I was
It's an hour.
talking.
explanations.
That's been
I
all.
got that.
Or here's the-
I mean, it's
Or
one
view as opposed to what we can demonstrate as the
I
reality.
got like a 3.
Well, here's another
I'm
problem.
waiting.
Like, I didn't even see this, it's like, assuming, what they're talking about is like a rippling in the fabric of space that created a nice little gravity. Now,
I think that'd be great.
if
Because it's
this
kind of
ripple
absurd.
were actually,
Just absurd things.
like involved space itself, any kind of motion in space itself would affect everything at the same time. It's a whole Thornhill, so it's like, you wouldn't go
That's why you have to million years old.
like some small amount of time apart. There would be some,
You have to
you
figure.
know, so I mean, for that reason.
Well,
Yeah.
that's, that's
Okay.
my sort of
If
roadblock.
space itself was moved,
Understand-
and you're just gonna carry everything in the space with it, it's just gonna move around everything. Either way, it's not gonna move any one part of the space. Right? And the fact that they're planning anything new, like,
Okay.
you know,
All right, we'll keep in touch with
It's like
them.
energy that's
I enjoyed it.
It's,
Danny, the best vaccine is
This is,
this is
look, Kesha, 150 years ago,
well, and I think people also need some basis to, there's gonna be a lot more discussion about this. You heard about
The
this.
guy could have started taking up position.
About the celebration of this Einstein theory.
And they could scream and holler and call you names and do anything they
Oh, it was a
wanted.
big news
What
item
happened
over
to
the last
destroy
week and a half.
Can we?
Put him out there flipping hamburgers.
Well, that's what I do with these,
When the scientists all get these, and they all have to
Bringing
walk
these
the
tiny little
step
pieces
around the door.
Yeah, you see,
But energy isn't coming off.
what's coming off is,
I know.
Exactly, I'm telling you, that what's the the green situation is exactly what
you
you're
know, the
doing.
reason why you need a trillion
And I get a
electrons.
People were all just walking lockstep while the like robots.
Right.
You know, the government's been and looked at this community where it's told you to
Really, I turned.
So the accelerators are about 17 mile circumference. It's got huge detectors. And look at the trace.
I know. I turn on 5 minutes of the news. see them in the
Best way is
morning,
that
I
you
watch
have a
them
special
in
watch.
Today
Yeah,
Show,
I think it's like-
and after 5 minutes,
Find out what
that's pretty
that
good, got a good sense of what's going on. Propaganda, this addition into the population.
But it doesn't explain.
I'm ready to go.
Yeah, right, so I see that, I understand. Well, but the thing that I would, becomes how we investigate what is the cause of their how it becomes produced, how neutrons kick out, but how they actually brought into the
Well, you know what they do, and this is.
LaRouche had his eye on Mark O'Malley.
They say, well,
When
the
Mark O'Malley
first
was good prosecutor, then he dropped out. I should say, suspended his campaign. Because he
So what they do is
was
they
outside the
reverse
vote.
the movie, and they say,
And,
well, it must
for
have
some
come
reason,
as
he
a
was pressured out, so.
Basically,
Well,
and they just extend it.
now the other side of
like
the
every door and window in the house works except for one, you got this one window that's
And they come
I
up, well,
don't
it
see
must
any
have
of them that would have it in there.
It doesn't.
Not right now. Not right now.
The other one that said anything back here now.
supposed failure.
Yeah.
My
That, to me, that's kind of-
Was who?
Tried to
Just
detect
like
promotion.
American great.
Really?
Yeah, right.
He stole that.
Yeah, right. So that's fine. I mean, that's what Americans want to hear, and I don't blame them.
We
You
know
gotta have some more substantial,
Right.
but we don't know if it's in
like it's in there.
So
But, you know,
how are,
Yeah.
how are
Think about
these
it,
things
waterfront.
found together if we don't even know what they're made of?
Okay.
It's all 60,000.
Yeah.
But that's the
Get it
advantage of this
Right.
LIGO experiment, is that
Which I think is.
we don't know what we'll find from
Basically,
additional waves. Because
You gotta have
if you
something
have a
to
more
break it
sensitive
but
detector,
they
What do you
didn't know
want?
what
I
an answer was.
checked it all out.
Yep.
so we might be able to.
LaRouche campaigned for it when he ran
What's-
for
what's
office.
inside?
Way back in 1980.
In a speed of like going one direction.
Well, I mean,
and the other.
it's-
Tell the world that we'll have to do it then.
Imagine if we'd done that. Imagine California and the whole West Coast was down in a terrible drought.
And, so, there's a lot of things that are okay.
Never. Never had to happen. So you see how
So we can see a lot more in the universe.
Right, it's a third
On this
dimension.
one.
you kill the people that fight for the ideas, then you kill the
But
ideas.
right now, we can see all these massive processes, and, you know, of course, I guess we
That's a good
hope
idea.
to be able to see something are a lot less.
It's dependent upon relativity, but they just swept it under the rug. You know, let's just
Yes, collide.
talk about it. You know,
Nobody,
that's one problem. The other problem
that we know of, could benefit from that.
that
Well, if you can tap that energy.
you know, the experiment did fail, it's got two better units at least, so.
I
You
was,
know, explain why there could be, you know, one light.
But I don't know what, I should have mentioned this, but we're like,
One way would be to assume that.
problem
stage
solved,
of
because she
the
had,
19th century.
she had,
When people looked at the
radiation as
sun,
a child to deal with cancer,
man,
to take garbage.
One way would
all the
be to
But, you know, that's
assume
way
that
back when,
sensory
it was
itself
very,
is correct.
what's
and
replacing
light
that
itself
energy?
is an
All they have is
instantaneous
chemistry.
what they do today.
And
So they
of
said,
course,
well, there must be a
substance
chunk
it
of
doesn't matter outside of
super
the
hot.
and you shine the
That
flashlight,
doesn't explain how.
you know, it's really instantaneous, then, you know.
Until we figured out
Well,
all
he
this,
said
we had no idea that it was usual.
discrepancies in
So we're
the
kind of like new girls in the 18th century. We had
And the other way to explain that
figured out, not
is to assume that you've got these particles.
know how to
Okay,
mix.
look, let me explain what I call the red.
Yeah, we know how to mix hydrogen and cause fusion.
Basically,
Giving
you know, it
catechism.
says that you've got this wave particle duality of light, which says that
These
light has the
gravitational
properties of waves and particles now.
Yeah.
Suppose you've got Teddy Roosevelt out there in the search where he's got a new rifle. He's got 2 or 3 new guys, and he's got a bunch of people, fence people,
You know, we had
Land Rovers and whatnot. He calls one of these new guys over, and he says, look here, we got some lines.
So anyway, it's fun.
Down
I
over here,
got
I've got some elephant dung over there. What do you think?
domestic things to take care of.
All right, we'll show you what's
Right
right
here.
Intro-
Right answer, well, boy, you know, what that means is, we've had some lions that have been here through here,
It was
some
like-
elephants have been through here too.
It was
That's
a
what I did.
battle of the brains.
Let me tell you the wrong answer.
Yeah, yeah.
Wrong answer is, well,
Yeah, I've never
what must have happened is, some
Killing right
kind of magical animal, probably both elephants and lions came through here.
No, They don't.
I know business, but I don't
That goes
know
like
that
the
kind of
teaching job, you see
level
what I'm
of
saying?
intelligence.
Now,
To me,
when you see,
it's a belief.
when you see
You weren't there at the
like
time
these
that this happened.
particles in
All you
waves,
do is believe,
what's the
by
simplest
researching
explanation
and
you could possibly
studying.
be?
But that doesn't mean you were there at the time that it happened.
Particles in
So
waves.
how well do
But
you
you
really
can
know?
use, for instance, if you
Here's what that means to me. That says that what you've got, like streams of these
Right.
you don't have to know.
but you're given all by energetic processes, which could be a fire, it could be plasma physics, so you like the neon light, could be
True.
like one of those
But
lights.
you use it.
So
So
any kind of thing which doesn't create.
Yeah.
Right.
But we had
All these things I believe are meant to kind of sell like aren't And as these things travel through the air, I believe they create shock waves, the same way with the bullet does in the air. So this is like all these things about an analogy. Like, look,
Well, that's.
there's one place in Washington DC.
Yeah, right.
Go back to shooting at more than 200 or 300 meters. This is gonna be the Marine rifle.
Oh, I believe that.
It's
They can test it, just like.
gonna be the
test
Marine
on
rifle,
people.
they took apart the elevator and stuff, 35 miles, so it's DC,
And you use a different element.
there you have a range where people shoot out to 1,000 meters.
Right.
They like the Marine
And
snipers, right?
they figured out, like they.
And you have people that pull, okay, you've got like a berm about,
Antarctica.
you've got a dirt berm about 100 feet.
They can test that.
Below that, you've got people that pull targets, and put the separate targets up at street level, right? And you hear the bullets go by as you, well, you know, and you're not in any way from the bullets, because the bullet has to go through 100 feet of dirt to back in order to hit you, right, it's perfectly safe. But now, there's two components to the self-gunfire. You've got the muzzle crack of the rifle itself, which is gonna be very loud if you're standing 5 feet away from it, 600 meters, you're gonna be able to hear it. Okay, but then the other component of the sound of gunfire is the sonic crack of the bullet itself, assuming you've got a rifle. You're shooting bullets which are supersonic, right? Now, if you're standing at point targets below this berm, you got bullets flying overhead, and people shooting like 600 meters away, you're not gonna hear the muzzle report.
Well,
It's like
it's
you're
a
gonna
mixture of the gravity plus the motor and the power.
The sonic crack of the bullets is still gonna be loud enough for you to hear. It's still gonna be protected. Well, I mean,
Right.
I gotta go finish something, but I have, you send me what you want to finish, and I have to
Just
take
real
everything.
quick, this is one of those somebody that didn't know better could make a mistake when you heard these bullets flying by with that. Could make a mistake of thinking, well, how long did they wait now? I'm hearing a sound wave. You didn't see the bullet. I'm hearing a sound wave. It must be, you know, I know that was a sound wave, like 600 meters away. It must be, you know, some sound travels like about 1,000 feet per second, right? It's like, maybe it's 1,000 feet, 1,000 meters back, right?
There's always.
Okay, you get the idea, right? It's like, it must be the amount of time that it took for that wave somewhere from here. Was the distance divided by the speed of sound. They were going about 2.5 seconds. Must be that sound wave took 3 seconds to get there. That's the wrong answer.
It's a wonderful
Right
thing.
answer is
It's
that
technology.
Well,
There's
what
different.
she was
I
pushing.
wow, we got a science class going.
What she was pushing.
As far as I'm concerned, it's everybody.
Oh, it's like you live right into it.
And so that,
That's cool.
what I believe that we're really seeing is light.
This experiment.
Yes.
I don't think it's like,
Absolutely.
you know, billion years from now. I think it's happening. It's
Everything in the emergency room of the hospital.
Couldn't
It's
detect
developed
any
out of
which
space.
Computer's necessary
Yeah.
speed of a subway.
So I never knew that
Until
I was around this
I
movement.
believe that's the kind of speed.
But you just realize, you know,
And you
before
can
they
see
were
what
born,
we're talking
a lot
speed
of
and what's the light wave that is. We don't see the particles, we see the waves they create.
What
Just like you do.
Yes.
just like the sharp thing in front of the bullet, you know, it's a side crack.
So you see.
Suicide. Everyone knows better.
I believe that
Silent
the
crimes.
ways that we see that
It's
we
a
call
crime
life
against humanity.
are
So we're gonna solve
created
All right,
that.
well, I'll see you
I'm
next,
at least within our own
I'm gonna have to
environment.
I'm getting
All right.
Okay.
coughing.
And, you know, apparently once we're inside our own solar system, it's like they come to us at the speed of light, right? Well, I believe when they get here from other places, it might be more like the speed of the subelectron particle. And,
Hey, Joel.
yeah, once you
You
understand that you're looking at something that's different here on
You want
Andromeda
more
in second
cookies?
two,
Yes,
then
go
whether
to
you know, like when I'm going on a train,
You're in
and
the kitchen, now you have to go to the kitchen. Oh, is it still going?
Yeah. Hi, bye.